Solving problem number 7, there is a given function and the first question is to find the derivative of x. So we can simply write the derivative of x, and this is equal to 3x squared minus 12x plus 9. For letter B, find all solutions of the derivative of the function. So to find all the solutions, so we equate this to 0, and then we can factor out 3x squared minus 4x plus 3 equals 0. This gives us 3x minus 1, x minus 3 equals 0. So this gives us the solutions where x equals 1 and x equals 3. For letter C, find the values of x for which the function is increasing. So the function is increasing where the first derivative is greater than 0. So we can use the sign diagram. Let's say we have here our critical points 1 and 3, and then we can test on the values near to 1 and 3. Let's say we use 0 here. So by substitution to this function, so 0, 0 that give us 9, so positive here. So let's try to use 2 here, bit closer to 2 and 3, and substituting it here, we'll get a number which is negative. And then let's say, let's use 5, 10 or something here, and substituting again to the f prime of x, we'll get positive here. So we can see that the function is increasing where x is less than 1 and when x is greater than 3. So these are the answers for C. For letter D, we have to get the second derivative. So that's quite simple. We get the derivative of A. So letter D, second derivative of x shall be equal to 6x minus 12. Okay, letter E. Hence, find the turning points and inflection points on the graph of f of x. First, let's find the point and then determine whether the extrema is minimum or maximum. So for using the initial point f of 1, uh, 1, 2, 3, 4. So for E, let us determine the points first, f of 1. So our f is this one, 6 times 1 plus, okay, so we will be getting y value. You can, well, I don't have enough space here, but you just have to substitute for your x equals 1 here, and you will be getting a value which is equal to 8. So that will give us 0.18. And then we can also substitute for f3 because these are the solutions. So we will be getting an answer which is 4. So therefore we'll have coordinates 3, 4 along that function. So we will determine uh, whether these are maximum or minimum point. We can use, of course, the either first derivative test or second derivative test. I would like this second derivative test. Second derivative test shows that if this is greater than 0, we shall have minimum. This is in the rules of our discussion. So if I substitute this from, where is this one? Let's say 1 8 for 1 8. So 6 times 1. So 6 times 1 minus 12 gives me a negative answer. If I use 3, 6 times 3 minus 12, I'll have a positive answer. So again, if it's greater than 0, it's minimum, and otherwise it's maxima. So 1 8 is, since it's negative or greater than 0, this is the maximum point, and 3 4 is the minimum point. The answer is greater than 0, minimum. Okay, so these are the answer for CI. Then I have to find the inflection point. So to find the inflection point, I can use the second derivative test. But I have to find where that critical point is. So second derivative test, uh, 6x minus 12 equals 0. I have to find a critical point, and that is equal to 2. Now I have to find f of 2, or the y value of that. So again, using the original function, substituting it, I will get 6. So my inflection point will be at where x equals 2 and y equals 6. That's for part 2. Now for the next part, let me erase this to give some room for equation. I have the equation f of x, this one, has equals k, has 3 solutions. Find the possible values of k. It has 3 solutions, but we're looking for the value of k. So if we're going to roughly draw the figure, let me draw. Since it's cubic function, it looks like S, but it has 1 8 here. Let's say this is 1 8, and then it has 3 4 here. Let's say 3 4. So probably it looks like this. And f of x equals k, or say y equals k. So we're looking for the values of y. So we can see that it ranges from 4 to 8. So here is your k in between these two values. So these are the possible values of k. Will not include the maximum and the minimum.